Hey everybody. In class today we talked a lot about the xy coordinate plane. Tonight we're going to do a little more work with x's and y's, but in this case it's going to be within the context of functions. Now, a lot of people overthink functions. They think functions is really complicated. All a function is a relationship that pairs each input value with exactly one output value. So it's really just a mathematical relationship where we take an input and it gives us an output. Input values, when we're working with functions, are usually represented by x. We use x as the input and we use y as the output. Output values are usually represented by y. Now, if we look at these four examples here, we want to be able to tell if each relationship is a function or not. So going back to our definition, we need to see that each input value is paired with exactly one output value. That means each input always has to go to the same output. If I look at example A here, I see that when x is 0, when the input is 0, the output y is always 5, right? So that's great. If the input is 1, the output is always 2. You don't see any other situation up here where 1 as an input gives us a different output, right? If we had 1 and -3 as the input and output, then that would not be a function because it's not going to the same output. 2 always goes to 2, and 4 always goes to 1. So because each input always gives us the same output, this is a function. Okay? Even though 1 goes to 2 and 2 goes to 2, that's fine, as long as 1 always gives us 2 and 2 also always gives us 2. Still a function. In example B, we have 2 goes to 0, but we also have 2 going to 1. In a function, the same input always has to give us the same output. An important word when we're dealing with functions is the word predictable. I'm going to put that up here. It's predictable. That means when I use 2 as my input, I need to get the same output. And here we see that's not the case. 2 can't go to 0 and to 1 because then we don't know where it's going. It's not predictable, so this is not a function. In example C, notice we have -2 going to -1, 0 going to -1, +2 gives us -1, and +4 goes to -1. The same input always goes to the same output. I don't have -2 going to another number. I don't have 0 going to another number. I don't have 2 going to another number, or 4. 4 always goes to -1. Right? So this is a function. Even though the same output repeats for every input, that doesn't matter. As long as I know what I'm going to get for each input every time. And in example D, I have -3, -2, -1, 1, 2, 3, and 5, -2. All of these are consistent. They're predictable. -3 always gives me -2, -1 always gives me 1, 2 always gives me 3, and 5 always gives me -2. So this is a function also. We don't have any of the inputs going to two different numbers. That's the key. Now, besides function, there are two other vocabulary words that we need to be aware of for working with functions. One is the domain. The domain is just the set of all possible input values, or x values. Right? So all of the inputs are in the domain. And the range is just the set of all possible output values, or y values. So for example A here and B, we're just going to go back to the A and B we had on the last slide. We're going to find the domain, and we're going to find the range. Okay? Now, the domain here is just the input values. And when we're dealing with a set of numbers, we put them inside these curly brackets, and we just list them. 0, 1, 2, and 4, right? those are the input values. The output values, right, the range, are these values. So use the curly brackets again. Now, I'm only going to put the values that get used. Because 2 gets used twice, I don't need to list it twice, right? 2 is an output value, and then 1 is our third output value. We only have 3 different values. So that's our domain and range for example A. And then example B will do the same thing. And example B, even though this isn't a function, it still has a domain. The input values 2, 4, and 7 is our domain, and our range is 0, 1, 2, and 3. All of our output values. Alright, so we've seen functions represented as tables. We can also represent functions as equations. In our first example here, we have an equation y equals negative x plus 3. Remember, x is the input and y is the output. So if we know a value for x, we can find the output. So in this case, we want to evaluate the function below for x equals negative 5. If x equals negative 5, what's y? So we can do that by just substituting for x. So we have y equals negative, and we'll just substitute negative 5 in for where x was, plus 3. Notice everything stayed the same. I just replaced the x with negative 5. And now we evaluate. So y equals negative negative 5. Negative negative 5 is the same as positive 5 plus 3. And that is going to give us y equals 8. So to evaluate a function, all we do is substitute the input in, and that'll give us our output. Now, sometimes we want to generate a lot of different outputs from a function. In example F here, it says create a table for the function below. So we're going to start from an equation and go to a table with the domain of negative 3, negative 1, 0, and 4. So remember, the domain represents our input. So we have 4 input values, and we're going to get 4 output values. So let's create a table. Now, I know my input values are going to be negative 3, negative 1, 0, and 4. And I'm going to put a little space in my table for the work that I'm going to show, just to make sure I can keep track of everything. And then we're going to find out our y values over here. So y equals 3x minus 5. Let's do our substitutions here. Y equals 3 times negative 3 minus 5, right? 3 times negative 3 is negative 9. Negative 9 minus 5 is negative 14. And now I have my x value here, negative 1. I'm going to substitute that in next. We do the same thing for all of these inputs to find all of my outputs. So 3 times negative 1 is negative 3. Negative 3 minus 5 is negative 8. We'll do the same thing for 0 here. 3 times 0 is 0, minus 5 is negative 5. And we'll substitute 4 for x. Our last one, 3 times 4 is 12. 12 minus 5 is 7. So here we have all of our output values, and we could even list the range here. We could say the range we'll use our curly brackets, and we'll just list all of our output values: negative 14, negative 8, negative 5, and positive 7. Alright, so the big takeaways for tonight: what a function is, how to identify a function, the domain, the range, and then evaluating functions, either for a single value or for a table. So you guys can go ahead, wrap up your notes, and submit them through Canvas, and I will see you in class tomorrow.